that are interested the presentation itself, so the PowerPoint, maybe as a PDF, you will receive a survey after the event where you will be asked whether you want to have a copy. So if you want one, please tick the survey. And if you have questions today, if they are answerable right away, of course, we will, and Masako-san will answer them today. If they're a little bit too complex or they require too much time, you can send an email to the address that I will indicate in the chat window during the event, and then we can move on from there. So without further ado, I would like to start a very short presentation to introduce you to the help desk for those of you that don't know me and don't know the help desk. And then I would give the word to Masako-san. So, yes. Perfect. So the help desk, as I said, is a service that has around 5 years. Starting in 2016, we do help companies and academia and research institutions. Like today, the target audience and target in terms of clients that we have are usually, they have to be in a COSME related country. So just to give you an idea for those of you that don't know, COSME is a little bit enlarged area compared to the EU, and Japanese companies, universities, research centers, and individuals. We try to help these people, organizations, institutions in navigating the complex world of IP, understanding what it means technology transfer, how to make a deal, how to do a little bit of matchmaking, meeting potential new partners. And we do that usually through the helpdesk's website, which you see here. Don't worry, you don't have to take notes. You will receive the presentation, so you will have the time to look at the website if you don't know it. I will go through some of the very important services that we offer through the website, and then you can have the time to go through it with more time after the event. We do have available technologies like the one that we're showing you today. So universities, research centers can upload technologies for free. They can go on the website. They can, of course, give me a call. We can talk. We can create a page for each institution, like you see here. We can upload one or multiple technologies, and then we can, of course, together with the institution, maybe tailor, custom make a strategy to approach potential licensees. The one of today is a typical, I would say, example of what we can do. This is the first time that we do it with our friends of Shiga, and hopefully this is not the last one. So this is just the beginning. This is the so-called push approach. So we are trying to push technologies out to the rest of the world, but we also take care of the pull. The pull is completely the opposite, as you can imagine. So we try to talk to companies and to listen to them and see if they have questions, if they are looking for researchers, if they're looking for technologies. They want to run an R&D project or run a POC with a startup. And we try to help them. So we have a section of the website which is dedicated to this, and it's called Request for Proposal. So if you are a company today, if you work for a company, you're interested, please give me a call. I'll send me an email, and we can talk more in detail about this kind of offering too. We have a lot of resources. We have webinars, like today's webinar, of course, which will be uploaded in no time. We used to have seminars, and probably in the future, hopefully we will start again having seminars in Europe and Japan. We have a podcast channel. We have reportage of all the events that usually we attend, online or offline. And we have a very useful fact sheets on IP in the sense of how can I get a patent in Japan, how can I get a patent in Europe, and the partners usually help us in covering these topics. And so we have pretty interesting and updated documents that might be of interest to you. So I kindly ask you to take a look at the website when you have time. We started the IPR support program that is here on the slide in 2018. And of course, Shiga is also part of this program. We do try to help companies, research organizations, individuals in understanding whether or not they can secure their IP rights, possibly also maybe how they can monetize them. And we do that through a program that is very simple. You just have to send me an email, And then, of course, we can set up the first meeting, and then you will have the chance to talk to a lawyer or patent attorney, and then eventually consider whether or not you want to move on and get a quote, etc. So it's pretty easy. We have a lot of social network channels, so you can follow us if you want. And here are my contact details, my email, again, the website, and also the physical address of the EU Japan Center in Tokyo. Without further ado, I would like to introduce Masako Yamazaki that I mentioned to you earlier. She will introduce us to the technology. And as I said, please do, if you have questions, please write them in the chat window, and we will collect them. If we cannot answer them today, we will be happy to send you an email afterwards. So without further ado, but also maybe give me 1 second to introduce Professor NAKAHATA and his background. He's a professor of the Graduate School of Science and Engineering, Civil and Environmental Engineering at the Ehime University. And the specialization research areas in his case are manufacturing technology with mechanical, electrical, electronic, and chemical engineering, machine materials and mechanics, non-destructive testing, and ultrasonics. Social infrastructure, civil engineering, architecture, disaster prevention, structural, and systemic engineering. So without further ado, now I give the floor to Masako. Thanks for introducing us to this technology.
Okay, hold on a moment.
And maybe I forgot, but Masako is in charge of the overseas unit of overseas clients here at Shiga.
Sorry for a moment. Luca, thank you for your kind introduction. Okay. Hello, everyone. We appreciate you taking the time to join this webinar today. It's also my great pleasure to introduce a cutting-edge technology derived from Japan's university. Let me allow to turn off my video on. In this presentation, we feature ultrasonic imaging technology for road pavement inspection, developed by Dr. Kazuyuki NAKAHATA of Structural Engineering Laboratory, Ehime University. Before I introduce the technology in detail, please be informed that this presentation contains an invention related to a pending patent application in Japan. So we kindly ask you to keep this confidential and use it internally. Your cooperation and understanding will be highly appreciated. As of today's agenda, I'll first briefly mention what kind of problems lie in the field of road pavement inspection and what solutions should be taken by illustrating the conventional technology. Then, I'll introduce you to Dr. NAKAHATA's invention by explaining how this invention would achieve the problems, suggesting some experimental results. And finally, it's the most important part. On behalf of Ehime University, I'll make a business proposal to potential licensees so that you can consider whether the technology would fit into your business and how you can leverage it in practice. And I'll also touch upon the prototype of the invention and patent information and licensor Ehime University. I hope this presentation will be entertaining and informative to you. To begin with, let me share with you the goal of this presentation. The goal is to find a business partner and licensee for the technology. As mentioned, the invention is now under patent examination in Japan and will be filing a PCT application this summer. So it would be desirable if a licensee or business partner will be able to assist them with the payment of PCT filing fees. Let's move on to the next slide. Current situation of non-destructive inspection for asphalt and concrete pavement. As you know, earthquakes frequently happen here in Japan. It urges necessity for inspecting road pavements on a regular basis, and so research and development on the technology has been active here. Asphalt pavements consist of porous materials and has multiple layers. And looking at the composition and structure of asphalt pavement, you can see several layers: top, base, and upper road bed and lower road bed. And also concrete pavements have compressive strengths and are more durable. Unfortunately, there is no definitive method for detecting the location and the size of damages inside pavements. By using non-destructive inspection, such as ultrasonic inspection. So in most cases, flaws or defects in roads are repaired on a band-aid approach. In addition, compared with ultrasonic inspection in metal media, road pavement inspection required high voltages to transmit the waves with high amplitude, since the elastic waves propagate through underground structures. So it means the road maintenance and inspections are considered to be a kind of large-scale project which require time and labors. That said, a web of road network cannot terminate its operation due to its important function of our transportation system today. Next slide shows the conventional technology on road inspection. Falling weight deflectometer, FWD, is a popular method of non-destructive testing for asphalt pavement in Japan. It's an apparatus of structural evaluation for asphalt pavements. During the testing, the deflection on the surface of the pavement caused by dropping large weight on the road is measured simultaneously at multiple points. The results of the testing is described as the deflection curve here. This inspection investigates damage state in ground, but cannot determine the size of defect. So to validate the inspection, further visual inspection inside the road is needed. The problem to be solved in road inspection is to find the location and the size of defects precisely and promptly. If the inspection has been done with ultrasonic waves, the location and the size of cracks are detectable. And here is Dr. NAKAHATA's invention. Phase array ultrasonic testing system using the FASP technique. Phased arrays are often used to detect and image defects and cracks in structures. Phased array UT is mainly used for medical image diagnosis and non-destructive inspection for mechanical engineering. So what is the FASP technique? FASP is an abbreviation of full waveform sampling and processing. The FASP is a post-processing beamforming technique that utilizes complete set of signals of all combinations of transmission and reception elements of an array probe. After acquiring all the waveforms from the computer memory are processed, and the focused beam is reconstructed while giving a time delay by post-processing. The figure on the left shows the flow of data processing using the technique with array of low frequency elements. So how this invention described in the Japanese patent application? The title of the invention, Ultrasonic Imaging Device, Method, and Program for Visualizing the Inside of the Road Pavement. Claim 1 states an ultrasonic imaging device using an ultrasonic array probe comprising 6 units, namely a parameter input, wavelength setting, element control, and storage, signal processing, and display unit. And it's used for testing a multi-layered structure, including a porous layer inside. The flow of data processing is shown in this figure 1 of the application. So when this technology of road inspection puts into practice, arrays of low frequency elements sample data inside the pavement by transmitting and receiving elements of an array probe. And then the collected data is processed by beamforming technique. And after acquiring all the waveforms, images capturing flaws and defects are generated with real-time processing. So this technology is unique in that the most appropriate frequency for inspecting asphalt pavements is selected based on numerical simulation, and the special arrays are designated. The FASP technique enables real-time imaging with GPU computing. The imaging process takes only 0.5 seconds. It allows sending, receiving of pulse, burst waves with high voltage. Now I'll delve into how it works, showing the experimental data. The specimen is a concrete structure covered with asphalt, and artificial cracks are formed in the specimen. You can see the depth of the slits by color, marked in blue and red. The experiment results shows the size and the location of slit are accurately predicted, and slits located at 1 meter depth can be found, and small defects which may cause destruction can be predicted. And this slide shows the rebars, iron pipes, and PVC pipes are embedded in the specimen. As the experiment shows, the present technology enables non-destructive inspection of the cracks or defects which cannot be seen on the surface of pavement but exist in pavement or below the pavement layer. Now I'd like to refer to the patent information. The status of the patent is described in this slide. The application was filed in August last year, and the PCT application will be filed this summer. Since this is a pending application, a scope of claims could be modified in accordance with your preference of your business coverage. So far, I have discussed the current situation on road pavement inspection and Dr. NAKAHATA's invention, ultrasonic imaging technology with the FASP technique. In the latter part of the presentation, I'll focus on business proposal and licensing process. In advance of considering potential license, let me reiterate the advantages of the present invention. First, it's easy to use and customizable. Since this invention can be utilized by implementing the software, a licensee can easily adjust to their business style. And second, it offers high-resolution image in real-time processing when inspection is carried out. And third, the technology is applied to a wide range of materials from metal, fiber-reinforced plastics, and porous materials. It also enables a cost-effective inspection. And you can obtain precise inspection of defects at an early stage. Here are business proposals to potential licensees. For inspection device manufacturers, by installing the software in your own device, real-time image processing is available with GPU computing. And non-destructive inspection using ultrasonic waves for a wide range of materials is possible, and you can implement software in your own inspection device. And for business users of non-destructive inspection device, the invention helps you detect flaws in asphalt pavements at an early stage, and it reduces maintenance costs. It also saves time, costs, and your energy compared with destructive inspection. You can tailor the devices in accordance with what it is to be inspected. The preferred frequency and probe structure are optimized. Your own probe can be used, or you may purchase a prototype. And this is a prototype. And the prototype of this claimed invention is on the market now. And this prototype is ultrasonic phased array device with high power pulse and strong burst waves. The prototype has some features and functions as shown in this slide. So far, I have mentioned in this invention applied to road inspection. But the present invention is expected to be applicable for a wide range of technical fields. As introduced in the patent application, this technology is related to ultrasonic imaging technology using an ultrasonic array probe, in particular arrays of low-frequency elements. When the technology is used as non-destructive inspection, its low-frequency range. It can be applied to concrete and asphalt pavements, which I mentioned previously, and also applied to infrastructures and industrial plants, such as tunnels and chemical plants, and in environment and energy, such as wind turbine blades. With high frequency range, it can be applied to aircrafts and vehicles made of carbon fiber reinforced plastics. It can also be applied to geophysical exploration for oil exploration and geological inference. And licensing process. First, licensing type. Ideally, Ehime University would like to make a non-exclusive license or joint research agreement. But any discussion on potential business is always welcome. If you have any interest of present invention or would like to learn more about the technology, please feel free to contact us, Shiga International Patent Office in Japan. We will be pleased to facilitate communication between you and the university, from answering questions to negotiating and making a licensing agreement. Licensing process and major requirements are mentioned in this slide. We provide opportunities for discussion and negotiation so that both licensee and licensor feel comfortable to proceed with this agreement. If you need the presentation materials, please answer to our survey after the presentation, and we will send you the presentation materials later. Finally, I'll touch upon the licensor, Ehime University, which Dr. NAKAHATA belongs to. Ehime University is one of Japan's national universities in Western Japan, and the region is well known for the Ohendo pilgrimage to overseas tourists. The laboratory focuses on the research of maintenance methods for damage evaluation and improvement of residual life in infrastructures. Ehime has successfully collaborated with local enterprises in various technical fields. Some of the examples of licensing activities are described here. If you are interested, please refer to the university's website shown in this slide. Let me take one or two examples of their successful licensing activity. One is fabric for protective cloths used for when decommissioning a nuclear reactor. It's a part of a commissioned research in conjunction with the local manufacturer. And another one is voice volume indicator for children with developmental disorder. This device assists the children in recognizing the volume of the voice of a speaker. As such, their unique technology have contributed to our business and daily lives. And this is the end of the presentation. Thank you for your attention. So I'll pass the microphone to Luca. Thank you very much.
Thank you. Thank you, Masako. The microphone and also the video. I'm back again. You were extremely clear, so I think that everybody is happy with your presentation. I would like maybe to give a couple of minutes if someone has some questions that you may want to write in the Q&A section here of the Zoom bar. And meanwhile, maybe I can ask you something, if it's okay with you.
Sure.
So you talk about the license, so the possibility to negotiate the different terms. So it's going to be very practical, okay? It's going to be a license with an upfront payment. It will be with just running royalties. And also, is there any difference? You talk about as a potential licensee, there might be a manufacturer or a user. So there's going to be a difference in these two kind of categories?
We will not make a difference between manufacturers and users, but with regard to licensing payment, we are considering applying milestone payment, but running royalty payment is also acceptable, depends on the situation. So the payment structure is to be decided based on negotiations in light of the company's situation.
Okay, that's the answer that I wanted to hear. Thank you. You know, this is the first experiment that we have between us as Helpdesk and Shiga, and the idea is to show, especially to companies, organizations that are outside of Japan, that it's possible to do some matchmaking and actually be able to have a licensing agreement. Okay, so I'm very happy that today we're doing this. Hopefully there will be an outcome out of today's presentation. And that's why I want to ask you maybe other questions, if it's okay with you, that are really maybe basic, but very practical, that can help people that are online in understanding. Okay, so for example, let's say that I'm sending you, I don't know, an email. So the process I would initiate if someone after today is interested in licensing the technology or knowing a little bit more, sending you an email, or how would it work?
Of course, you can send us an email. The email written here. Anytime.
Perfect. Perfect. Well, and anyway, if we don't have time now to take note, we said that we are going to distribute the presentation,
yes,
so people will have the chance to see the email. Okay, perfect. And then it will be you or some of your colleagues, I guess,
yes,
answering. Okay, perfect. And the first step is an NDA, or?
Oh, yes, that's right. First, a non-disclosure agreement is finalized, and then detailed information, including know-hows or etc., is disclosed to a licensee, and so that the licensee can consider its value, I mean, the value of the technology. And afterwards, we are going to active negotiation.
Okay, that's clear and pretty standard. So I remember that in one of the slides you mentioned the fact that slide number 17. Here you said that there might be also interest. The university is interested also in joint research. Maybe can you elaborate a little bit more on that? What it means?
Oh, sure. This research, which I mentioned in this presentation, has already been completed. But if there were to be any proposal of new or challenging or upgrading research, Ehime University would be happy to consider the joint research. So as I said in the presentation, any business proposal is welcome.
That's great. That's great. I saw that there was a question, maybe before I move on with the, I'm sorry if I have too many questions today, but I'm interested.
No problem.
So I saw originally a question that was about the fact someone asked if it's something that is a device mounted on a vehicle, or if it's operated by the user. I guess it's mounted on a vehicle, right? From the images.
Yes.
Yeah, okay, so that's the answer. But I'm sure that now, since we still have a prototype, or everything can be kind of right, adjusted probably also.
Yes.
Okay, good. Again, to be super practical, how long does it, because maybe people that are not from here, they would be a little bit scared about the language. Maybe they might think that everything has to be paper-based and mailed, and now maybe it's a little bit difficult. So how would it work if someone is interested and then there is a contract that has to be signed? Can be done digitally or the PDF?
Sure. Yeah, first, the licensing period is decided based upon how a licensee places its value on the present technology. So we estimate it take 1 or 2 months from the initial contact to concluding the agreement. But it may take more time depending on the negotiation. And second, the requirements of the licensing contract, it can be signed on a digital basis. And then we will send you a concrete version of the contract on a paper basis. And if you have any language difficulty in communicating in English, Shiga will be happy to be assistance of you.
That's great. That's perfect. That's perfect. I can see that there is another question here. Oh yes. Oh yeah, this is the answer. Perfect. Okay. So we got the answer directly from the source. So how, I don't know if there are any other questions here from the audience. What are the main advantages of this approach with respect to GPR devices? So I don't know if this is something that can be answered in the chat window, or maybe we want to address later. Maybe. Okay, good, perfect. So this today, if you want to take a couple of minutes to write other questions, it would be the best option, and then we can collect all the questions and have an answer for you. Maybe we can even provide for an answer in the survey. Maybe no, so that everybody can take a look, and it might require a little bit more time, and it's better to maybe put it in writing. Okay, does it make sense? Okay, and I'm sorry if you see me looking there, but because Masako is here, so that's why you see my face on a side. I think it's a great opportunity. This is the first technology that we have from the university. It's the first time that we have Professor NAKAHATA with us, and it is the first time that we do this together. Again, today is an experiment for us to see how to promote technologies outside of Japan, outside of a university, and reach out to potential licensees, in this case in Europe. And I think that we might have more and more technologies and opportunities. But this, and I'm now addressing the audience, is just a way to make also you understand that the purpose of the help desk and the effort of today with Shiga is to show you that it's relatively easy to be in touch with an institution here, and it's possible to talk and potentially also conclude an agreement and bring a technology from here to Europe, or vice versa. Of course, it might be also the other way around. I don't know if you want to add something else. Okay, good. So I can see here that there is only one question, so that will be easier to answer. And if there are no other questions, we were pretty fast today, which is good. And again, we will share with you the presentation. So if there are colleagues that today were not able to participate, you can share them the presentation. You will also get this YouTube, probably YouTube link or Vimeo. I don't know now which platform are we going to use, but it will be a video, so you will be able to share it. And again, you can contact Masako at the address that you saw in the presentation. You can contact me at the address you saw in the other presentation, and we are always open. So without further ado, I would like to thank you, thank the audience that today was with us, and of course, President NAKAHATA that is here with us as well. And hopefully I'll see you. Thank you, Professor. I'll see you. Nice to see you. And we can maybe give you the last word.
Okay. Thank you, everyone, in spite of your busy schedule today. I think in Europe, you might be doing this, watching this presentation first in the morning. So we are very pleased to have an opportunity to grant access to front line of technology derived in Japanese universities. And I hope to meet you all again soon. And if you have any questions and assistance, please let us know. Thank you for your time today. Bye-bye.
Thank you all.